So that was our problem number 1. First, we got the given, and then we wrote what has been asked, and then in noting the problem or what has been asked, we try to find solution, by knowing which equation to use. If we are going to use the constant acceleration or not. Okay, for our problem number 2, we have a figure shown here, no? So this is a rocket test. So the rocket shown here moves upward at 75 meters per second. So initial velocity is 75 meters per second. And when it is 40 meters from the ground, its engine fails. Determine the maximum height. So maximum height, you denote that as the position as reached by the rocket, and its speed just before it hits the ground. While in motion, the rocket is subjected to a constant downward acceleration of 9.81 meters per second squared due to gravity. Neglect the effect of air resistance. Okay, so klaro na kayo nga in this problem. We noted on the constant acceleration, so we can use the constant acceleration formula. Now, unlike the previous problem, nga wala taka ato pang i-try if the acceleration is constant or not. Okay. So our sample problem number 2, so giingon dire, so in mechanics we only not discuss about objects or particles motion along the right or the left or from forward to backward. We also talk about the motions upward or downward. So this is the example of motion along the y-axis. Okay, during a rocket test, so let's say this is the point where our rocket started or where it came from, no? So, ito siya. Ingon siya, rocket travels upward at a 75 meters per second. So, isaka do si rocket 75 meters per second. So these are a series of points. Then we use we use positioning with letters. So here, so atong initial velocity, we can use v1, but in this example, aron di na mo malibog as shown in your module, they use A. Okay? So let's say this is point A. Okay. So, and when it is 40 meters from the ground, its engine fails. Okay. So, isaka ni si rocket 40 meters from the ground. So, kaning 40 meters from the ground, this is position, right? So, we use S. So, ato lang gamiton nga sub ni S is A. It means, the position at A is 40 meters. So, yung velocity again, initial velocity is 75 meters per second. So, we use the velocity symbol at A. So, velocity at A is 75 meters per seconds. So mo ni siya, pag abot sa 40 meters, niundang na ang ang velocity. Okay. So, yung final velocity from this to here is 75 meters per second. And then, pag undang siyang velocity, wala man na siya ninaog diretsyo, saka pagyapon na siya, no? Hinay-hinay. Until such time, niabot siya sa point nga nihunong ni siya diri. Okay? Certain point, nihunong siya diri. And then, nibalik siya kanaog. Until sa nistabugsok siya. At this point. Okay. So, saan man nato? So, determine the maximum height reached. So mo ni siya ang given na to, ha. Ako lang i-write. Mo ni ang given velocity 75 meters per second at 40 meters height from the ground. And then we were also given that the gravitational acceleration is 9.81 meters per second squared. This is the constant acceleration, so it does not change due to time. So this is SI unit, no? Klaro kaayo. So we were asked two things. Yes, two things. The first one, the maximum height reached. And then, so we were asked here the maximum height reached by the rocket and speed just before it hits the ground. So this the speed before reaching the ground. It hits the ground. So we were asked again two things. Okay, so that was our two problems. So here we have point A. That's why we call it as A and VA here. And then sa yung pagsaka, di ba? May certain point nga mawala yung velocity, mahinay siya, muundang. Let's say this is our point B. Okay? And then sa yung pagnaog on this side, let's say this is our point C, as was given to this example. So, nalang ko reminders again. So, di ba? Position, velocity, and acceleration are vector quantities. So, our acceleration given here is 9.81 meters per second squared, the gravitational pull. Since ang gravitational pull is downward, so the acceleration due to gravity, we will use the sign convention na negative. So it will become a negative 9.81 meters per second squared because it is downwards. Okay? So, muna siya itong rule ha. Everything that goes up or to the right is positive. And then it goes to the left or downward, we use negative. Okay. So, muna siya. At point A, at a height of 40 meters and with a velocity of 75 meters per seconds, diba? Nisaka siya ni undang ang fail ang engine pero nagpadayon pa na siya saka. Until it reach ang point nga wala na siya ni saka. It is because the velocity on this point is already zero. So kung magpadayon na siya saka, muhinay gyud na siya tungod sa muundang siya at instant in an instant. So here, our velocity, let's say we call that velocity at point B is equal to 0 meters per second or just 0. Now we were asked the maximum height reached. So the point B is the maximum height, no? If we make a line there, we can name this height as SB or height at point B. SE is height at point A. And then speed before it hits the ground. So before siya hits the ground, this one, let's say as its speed man, we name it VC. Velocity at C. Okay. So now we have the conditions, the given, the problem. We already know that this is a constant acceleration. So we have several formulas if you recall. So we have the first one as the position or the distance is equal to SO initial plus the initial velocity times time plus and minus the half of the product of acceleration times the square of the time. Our next condition, we have the velocity is equal to initial velocity plus or minus the acceleration times the time. And then our third constant acceleration kinematic equation, we have the square of the final velocity is equal to the square of the initial velocity plus or minus twice the acceleration times the displacement, or we call that the final position minus the initial position. So, sa itong gamiton, class? Okay. At point A, we have initial, at from point A to point B. So, ano ni siya class no? Para mas atong pag-solve is di gid kay ta malibog. We divide this into points, di ba? It is because para dali ang ato ang paggamit sa equation. So, we have from point A to point B equation. Napoy point B from to point C or from point A to point C. Just it before it hits the ground. So, from point A to, so itong first is maximum height reached. That is our first problem. Followed by the velocity before it hits the ground. So, from point A to point B, given na to is velocity, initial velocity, VA, 75 meters per second. Initial height at A, that is 40 meters. And then at B, we are given the final velocity equal to 0 meters per second. But we don't know the SB or the maximum height reached. So, muna itong gipangita. So, aning tulo ka equation, unsa atong gamiton? So, in the first equation, na atay final height, let's say this is SB. Initial height, let's say this is SA. We have the initial velocity, let's say this is the VA. But we have time. We have acceleration, but there's no given nga time. So, in this equation, duha na itong unknown. We don't know SB or the final height. We don't know the time traveled. So we are not going to use this equation. The second equation, same. We have the final velocity 0, initial velocity 75 meters per second. We have the acceleration due to gravity, but we don't know the time. And then of course, well, we can use this to solve the time from A to B, but we are not asked to solve for time. We are asked to solve for the maximum height reach and for velocity before it hits the ground. So let's neglect this formula. Therefore, we are going to use this third equation. Okay. So this is it. No, from point A to point B, we are going to use this equation. So V squared is equal to V naught squared plus or minus 2 acceleration times S minus SO or FA. So V squared, this is the final acceleration. So in this our problem, the final acceleration is the VB. V sub B squared is equal to our initial acceleration from point A to point B. So point A, initial magid ang A. This is 75 meters per seconds or the VA. So VA squared. Para di ta malibog. And then plus or minus. So diri na to na makita ni acceleration. So atong acceleration is due to gravity. That is downward. So we use negative. So minus twice the gravity. So I use G because that is the gravitational acceleration. Times the final distance or height or position minus the initial. So atong final from A to B, atong final point is B. So it means this is the final distance or position. So we use designation SB minus the atong initial from point A man SA. Okay. Substituting the given values, we have VB squared, 0. That is 0 squared. It times equals to initial velocity squared the initial velocity, 75 meters per second squared. So meters per second squared. Minus 2 times the gravity, that is 9.81 meters per second squared. Times the final height. So we don't know yet the final height. That's why we are solving it. We're getting it. Minus the initial height. SA, which is equal to 40 meters. Okay, so this is it. So sir, why not we try to solve it from this good, from 0 good, there is a ground. So kung ato na i-solve, dili na to siya makuha ang kuan. So we have, you try it, 0 ang velocity, final, 0 ang initial velocity. So how are we going to solve the kuan? The problem. So there is an error in the problem. Okay, so we need a specific value nga naagi ka-exist. So from point A to point B. So kanisha 0 squared, so of course that is a 0. 0 is equal to 75 squared. So square of 75 is equal to 5,625. This is meters squared per second squared. Minus 2 times 9.81. So 9.81 times 2, we have 19.62 meters per second squared times SB minus 40 meters. So transposing this variable on the left side, on the left-hand rule, we have 19.62 meters per second squared times SB, final height, minus 40 meters is equal to 5,625 meters squared per second squared. So in order to solve for this variable, we need to divide the whole equations with 19.62 meters per second squared. So kung sa imong gibuhat nga operation on the left side, maupod sa right. Nag-divide ka diri, mag-divide pud ka sa pikas. 62 meters per second squared. So this will be cancelled. So on this side, so meters, square meters, mag-cancel ni siya, mag-cancel. Second squared, mag-cancel ang second squared. Remaining unit is meters. Okay, we're going to continue on the other side of the paper. We have the final or maximum height rate is equal, SB minus 40 meters is equal to, pila to? 5,625 divided by 19.62, that is equal to 286.70 meters. So, combining, so ang 40, i-transpose natin on this side. We have the maximum height reached is equal to 286.70 meters plus 40 meters. Then our maximum height reached is equal to 326.70 meters. Okay, so don't be shocked sa inyong given nga module. Ang gigamit niya is 327 meters. So, sa round off lang na nagbase, okay? I'd like to transfer the given drawing in this sheet again. So, this is the ground. And then, this is our point A. And then, notice siya, the engine fails until it's reached at such point. Wala na velocity and then panaog siya. So in this point, the highest point, we name that as point B. So the here at position A, that is 40 meters high. And then our velocity at point A is equal to 75 meters per second. Our velocity at point B is equal to 0 meters per second. Okay, auto, wala na siya velocity, hunong naman siya ang point. And then this is our SB, which is equal to 326.70 meters. And this will be our point C just before it hits the ground. And yes. So in this point, at point C, we were asked what is the final velocity, or let's say the velocity just before it hits the ground. Okay. So we're going to use again this equation, v squared square the final velocity times the square of the initial velocity plus or minus twice the acceleration times the displacement, or the final position minus the initial position. So in this given diagram, we can use two given. So we can use from point A to point C to solve this VC, or the velocity just before it hits the ground. Or we can use from the points from B to C. So I want to show you first the solution from point, let's say from point A to point C. So V, final velocity. So from point A to point B. So nagsugod man ta ni A, this is initial and this is final. So our final velocity then will be VC squared, or final velocity just for this the ground, set C. Our initial, gikan man ta ni A, so that is VA squared plus or minus, since there is gravitational acceleration downward. So our set convention is negative, minus twice the gravitational acceleration times the quantity of final height. So this is the height at C minus the height or initial height, or that is the height at A. So VC squared, this is the unknown, VA squared, that is 75 meters per second, minus twice the gravitational acceleration, 9.81 meters per second squared. Our final, or let's say the height at C, since it is just before it is the ground, Kamay na lang kay kamillimetro, we use a 0 minus height at A, that is 40 meters. Okay. So VC squared is equal to 75 squared is equal to 5,625 minus twice the 9.81, that is 19.62 times negative 40. VC squared is equal to 5,625 minus, so this is negative 19.62 minus then times negative 40, so we will have a positive, negative times negative, positive. So this becomes plus 784.80. So VC squared 5,625 plus 784.80, that is equal to 6,409.8. To get the final the velocity just for this the ground VC, we extract the square root. So our velocity at C just before it hits the ground is equal to 80.06 meters per seconds. So this is from point A to point C. Now we're going to use another method from point B to point C, just to show you. Okay. So from point B to point C, same formula. V squared, final velocity squared, times the square of the initial velocity plus or minus twice the acceleration times the final height minus the initial position. Okay. So from B to C, initial, final. So final velocity is VC squared. Initial velocity is VB squared. Negative acceleration due to gravity minus 2g times final height minus initial height. So our final velocity squared is equal to ato ang initial velocity at B is, if you remember, that is 0 meters per second squared minus 2 times 9.81 meters per second squared ng acceleration times SC is 0 and then position B, that is 326.70 meters. So we will have VC squared is equal to 0 squared, that is 0, negative 2.98, 9.81, so that is negative 19.62 times negative 326.70. We have the final squared final velocity, 19.62 times 326.70, we have a 6,409.8. So the square root of the equation, then we'll have a final velocity equal to just the other or the previous solution, 80.06 meters per seconds. So what is the direction? So velocity is a vector quantity, so we must include the direction. So since on this graph, this drawing, the direction of the object is downward, therefore 80.06 meters per second downward. Or we can represent it with negative 80.06 meters per second. Also similar to this equation. Downward. Okay?